this lecture we'll create our bird class, which will be handling our bird movement. So before that we'll create two methods which will convert frame to the millisecond and vice versa. So let's create that after this load image. So let's create it. So it would be just defining first frame, it should be frames to millisecond. So frames to millisecond, and we'll just get a frame and just give the default argument, that is the frame per second that we defined earlier. So basically what this frame and FPS is that basically we have there two argument, and this frame is basically how many frames to convert to the millisecond, and this FPS is the frame rate to be used in the conversion. So this FPS will have the default, that is this frame per second, that is the default frame per second here. So what we're gonna do is just you can just have here as a basically as a comment, so that you can reference this code after a long time even. So that would be like a convert frame to millisecond and at a specified rate. In this case the specified rate will be FPS. And now just use this agent, we'll just use agent. So it is showing some error, so it is indented expected. So let me just give a tab here, and we can do something that is okay. First what are we gonna do here we'll just return after some calculation. So that would be return 1000, and this is the way. You can also Google it to search what is the way to just convert frame to the millisecond. So it will be just multiplied by 1000. So this frame should be multiplied by 1000 and divided by this rate basically. So this is the way to convert to the millisecond. And similarly we'll have another function, and that will be millisecond, that is millisecond to frame. Now that will be millisecond to frames, let me say frames, and it will take our milliseconds. And similar the second argument will be the rate, so that will be same as before, that is the FPS here. And let's now just say something, that is here argument. We have a bunch of arguments, so there are millisecond argument is basically for just saying that is how many millisecond to convert for the frame, to convert from frames. So how many millisecond will be used, and this FPS is basically rate. So this is the rate to use basically for conversion, and the default here is our FPS. So FPS here was basically we assigned it 60, which is the standard for our Flappy Bird. So after that what you're gonna do is we'll just return something after the conversion here. So that's return FPS, and let me just remove this bracket. So FPS and multiplied it by millisecond here, and just divide it by our rate. So that would be not rate, that would be 1000. So if you just analyze this formula, it will be just exact of this frame to millisecond. So after this two method, what we're gonna do is just create the bird class. So just create here, that would be like class and bird, and inside this parenthesis now we'll just give something that will just inheritance. So there will be the inheritance, that means this bird can use the method basically, or all the functions of this basically inherited class, that means the parent class. So we'll say parent class will be pygame.sprite, that is the sprite dot sprite. So this is basically used to represent the bird, that is the bird should be controlled by the player. So this represents basically, this represents the bird should be controlled, that is controlled by the player. So this is the way to just give the sprite here. So let's visualize our game now, and just think for the parameters here, that is the base parameter for our bird class. That means the more you think, more you can discover the parameters, and better will be the functionality of your game. So let's see what the bird can do basically. So let me just comment it out here, so just show you that what the bird really can do. So firstly the bird can make it climb, so that means it can just move upward. And similarly, otherwise if it cannot, then it can sink. Basically it can sink. That sink means it can descends more quickly, so it can descends more quickly than it can climb. So basically here's the sinking part. And it can also, it must pass from the pipe. Basically it must pass basically through the pipe, and between the pipe. It must pass between the pipe. And for every that is passed of the pipe, so for every pipe passed, so 1 point is scored basically for that bird. So that means if it crashes into the pipe, game will be ended. So for that purpose, let's now uncover the attribute of the bird. So that means how this bird will work. Basically what are the attributes of this bird. So first attribute be obviously the x coordinate, that is the bird x coordinate. And similarly we'll have y here, so y is also the bird current position or the y coordinate of the bird. So similarly, what is the next thing that we can have is millisecond to climb. So this is the third attribute, and this is basically the number of a millisecond left to climb, basically where the complete climb lasts for the bird dot climb duration. So we haven't covered this climb duration. This will be basically the constant of the bird or the climb duration for the bird. So this basically, this millisecond to climb will be something that is number of millisecond. This is the number of millisecond left to climb, where the complete climb basically lasts for this duration, that is bird dot climb duration. So let's uncover the sum of the constants after these variables. So constant will be basically, first is width, and this width is the width of the bird in pixel. And similarly we'll have height obviously, and this height is the height of a bird image, and that is also in pixel. And we'll have this sync and speed. And sync speed is basically with this speed in the pixels per millisecond. So this speed is basically in the pixel per millisecond, and this is the speed the bird can descend in 1 second while not climbing. This is the sync speed, so it can just fall downward in the one, basically in this pixel, in the pixel per millisecond. So what if we have this climb? So we have a climb speed also. So that's the climb speed for us, and this climb speed, with this speed the bird ascends in 1 second while climbing on average, basically. So it is also in the pixel per millisecond. So what the last thing we're gonna have is climb duration. That is the fifth constant, and this climb duration is the number of millisecond. Let me just write here. So it is the number of millisecond. It's the number of millisecond it takes basically the bird to execute the climb, that is a complete climb. So this is the complete climb. So this is the number of millisecond that the bird will take to execute on the complete climb. So this is the important basically climb speed. And what we do next is the basically we'll just define our class variables now. So just go outside this commenting, and let me just write first width, and this will be the width equal to the height, and this height will be 32. So what this 32 is really about, is this the bird height? No, this is not a bird height, but this is particularly our width of the gap of our pipes. So when you run this game, we can just alter this value to check the width of the gap, basically of the pipe, and make our game more challenging. So if you type here of 50, that means there will be the more gap between the basically in the pipe. So 32 is just average gap, so just let me stick to 32. And now what the next thing we're gonna do is sync speed. And this is the sync speed, and I have told already that what is the sync speed here. So sync speed, let me say it is 0.18, and the name suggests sync speed is just basically sync speed is the speed that will just make the bird to fall. And similarly we'll have climb speed, and this climb speed will be something that is 0.3. so this is basically climb speed is smaller than the sync speed. So you can see here that the climb speed is greater, not smaller, that is greater than this sync speed. So it is really important. And now what we're gonna do is climb duration. And I've already written you here that what is the climb duration. So this is the number of milliseconds it takes the bird to execute a complete climb. So it should be larger, and let me see, it is 333.3. This is the basically what the time is, basically the time in millisecond that the climb lasts for. So first thing what you're gonna have in this class is obviously the constructor. So let's define a constructor first, that's the init and self. And this constructor will have self, obviously a parameter, first parameter. After that we'll have x, y, and second, that is millisecond to climb. And similarly we'll just have these images now. So after that, what is this basically init function? That's not, it should be init. And now this init basically have this, all of these basically parameters. So let me just comment it out here to show you what this parameter are. So literally there is the first parameter, that is there, this first param x. So it is a bird x coordinate. So this is basically bird x coordinate, and we have y, and this is the bird y coordinate. And similarly we have this param, that is millisecond to climb, this parameter. So this parameter is the number of millisecond, that is millisecond left to climb, and when the complete climb lasts basically. So this is the number of millisecond to left to climb when the complete climb lasts. And it will be all in the pixel, and we have converted here from the frame to the millisecond. So all the basically conversion will be in this millisecond and into the frame. So these two functions are really important. So here are the function, and images is surely the image that we'll deal with. So what we're gonna do here is we'll just have this, let me say here the image is the tuple. So let me just show you that image is tuple. Image should be the tuple, and this tuple should be containing image used by the bird. So every image that is used by the bird will be stored as a tuple inside this image. So this image parameter here is the tuple. So let me say this is just not containing, so just let me quickly fix that. It is, and now we're good to go. So let's define this init function now. So here firstly it will just call this parent class from this super, and super of bird, that is the current class, and just give a self here. And after this just call the init method here, and after that what we're gonna do is just self and just assign the value of x and y, that is the coordinate here from the x and y. When we call this bird class, we'll have this automatically call this init function, that is the constructor, and when you create this object of this class, init will be called, and automatically we'll have this self x and self y agent, stored agent from this x and y. Similarly we'll have to assign this self.millisecond from here. So that would be something that is sec, and it is not basically giving you any suggestion. So that is sec comma 2 and climb, and it should be sec, obviously sec to climb. So similarly what we're going to do next is self dot image wings up, image wing up, and similarly we'll just have similarly what it does next is image wing down, and that will be stored from this tuple containing, that is image tuple here. So this image tuple will just assign our image wing up and image wing down. So this is not image, let me say img here. It was our img, not image, and also it is img. This is basically our class variable, and you can say that is the basically what we get from the resources. So let me see and check it once again, image wing up and image wing down. So now we're good to go here. So after that, what we're gonna do is let's create the property marks basically. So for that, just define the marks function here firstly. So before that, let me just call up this firstly. After this, basically after this image wing up and down, we'll just have this marks first. So that will be called legend self dot and give the underscore and marks the wing up. This is for the masking purpose. And what you're gonna do here, so it will be age pygame dot mask. We have the mask function in this pygame, and let me say it is mask, and this from the surface. So just give a surface now. So surface will be obviously our self dot image wing up, that is image wings up. So we have now mask wings up. Similarly, we'll create that for the wings down too. So that will be the same procedure here, that is masking our instead of wing up, we'll just have our wings down, and that will have this pygame dot mask dot from surface, and give the surface again, that will be self dot image wings down. So we have also marks here. So we created our init function. Now let's create our property marks. So that will be like property, just give here a mask and just give here self. So after that, what you're going to have here is it will just basically get a bit mask, and that will be used for use in collision detection. So this is important, mask function. Similarly, what we gonna do is it will just bit mask will just exclude. So it will just exclude all the pixel. Basically, it will exclude all the pixel in self.image with transparency. So this is the way to just deal with this basically collision detection that is greater than 127. So it will just exclude all the pixel that is in this self.image, that is our tuple, and with the transparency greater than 127, so that it will just see the collision detection. That means in this screen, if the basically what if the bird just goes outside the scope, so there should be the transparency, and that can be used for the in case of the basically for the pipe also. So let's marks for the bird first. So that would be if pygame dot time, obviously dot and I'll say get ticks is, let me say percentage 500. This is basically a masking, so with the transparency to check for the transparency basically. So it will be greater or equal to 250. If it is greater or equal to 250, then just return, that means get out of the game basically. And after that, what you're gonna do here in the not only return, we'll just return with this self and mask wings up, not down, mask wings up. Similarly, else we'll just say that it will return mask wings down. Mask wings down is not image, it is mask wings down. So this is basically for the movement, for the basically using this property to get the bit marks for the collision detection for our mask wings up and mask wings down is basically our image. So you can see that for here, that is this is for up and this is for down, and just we use masking because we want to just use it for collision detection. So after this mask property finished, what we're gonna do will be, obviously this lecture has been a long lecture, so we'll complete our two conversion method in this basically lecture, that is from frame to millisecond and vice versa. And we also created class word and work with the constructor here in the constructor, and similarly we also marks this property here. So in this property marks, we can also have this at the rate and just give the property if you want. And similarly, what we also have here is we have not basically loaded our sprite and work with our logic yet, so we cannot run our game now. So maybe we'll run in the next lecture. So